Now, this is an interesting topic. I have already a piece of code available here. I have a base class having one function called void fun, and it is displaying fun of base. And I have a derived class having a function fun, which is displaying fun of derived, and it is deriving from base class. Now, already we saw that base class pointer pointing on derived class object. Let us do it. I will take a base class pointer, and to that I will assign derived class object. Derived class object. Base class pointer and derived class object. So object is of derived class. I am writing this time in a single line. Now, using base class pointer, I can call which function? I can call only those functions which are present in base class. So what is the function present there? Fun. I can call that function. But that function is overridden in derived class also. It's available in derived class also. Right? So there are two copies now. There are two copies. So in base class also that function is there, in derived class also function is there. So I have overridden a function. Now the question is, whose function will be called? Base class function or derived class function? Base class function or derived class function? Which function will be called? Listen carefully. Listen carefully. Base class is having one function. Derived class is overriding that function. Base class pointer, derived class object. So one class pointer, another class object. Now calling a function which is present in both. So which one will be called? Base class function will be called. Function is called based on pointer used here. Pointer. It is dependent on pointer. So that's it. So using a base class pointer, when you call a overridden function, then base class function will be called. Right? Remember this. This is what happens in C++. Now let us take the example of a real life and understand it. See, I have a basic car pointer pointing on advanced car object. This is an advanced car object. Pointer is basic car. Pointer, I am showing that there is a car, right, parked there. So I am saying basic car. Pointer, just a pointer, showing the address. But actual object is which one? Advanced car. Now I will get into the car. I am thinking it's a basic car. Now I will drive. How it will run? It will run how I am thinking, how I am calling, or it will run what it is. Will it run like an advanced car? This is an advanced car object, right? This is an advanced car object. So will it run like advanced car with that mechanism, or the mechanism what I am believing in? It will run like an advanced car. It will run like an advanced car. So when you call a function which is present in base class also, derived class also, whose function must be called? Based on the object the function must be called, not based on the pointer. Not based on the pointer. See, it is just like if you saw a donkey and say it's a horse. So will it run like a horse? You are thinking it as a horse, but it's a donkey. It will not run like a horse. When you run it, it will run as a donkey only. So same way, here basic car is the reference, and you are pointing on the advanced car object. So the object is of derived class, then pointer is of base class, and you call the function. That function is called. But logically it is wrong. Logically I am trying to show that it is wrong. Whose function must be called? The function based on the advanced car. So in C++ it doesn't happen. In C++ if you call a donkey as a horse and say run, it will run like a horse. That is the meaning. Now let us see how to make the function of derived class execute, not the base class. So for this, C++ is having a keyword called virtual. So inside the base class, you make the function as virtual, and when you override it, then if this is the situation that base class pointer, derived class object and calling this function, then this function will be called. This function will be called. So not that one, this function will be called. So this is what virtual functions are meant for. Virtual functions. So to give the real life meaning in the code, to make it just work like how the things work in real life, virtual functions are introduced in C++. So if you make a base class function as virtual and you override it in the derived class, then if you use base class pointer and derived class object and then call that overridden method, that one will not be called, this one will be called. So many things are there. It's not just a simple thing. Again I repeat, base class having a function, derived class is overriding it and it is declared as virtual, and you are taking a base class pointer and you are taking a derived class object and calling that overridden function. These all the things when you do, then this function should be called. Directly, if I say derived class D and I call d.fun, then which function will be called? The object is derived class, directly this function will be called. There is no question here. So the ambiguity is arising when you have a pointer of one class and the object of another class. Then the ambiguity is arising. So in that case, if that is not virtual, that will be called, otherwise this one will be called. So that's it. So to make the things work just like in the real world, you have to declare virtual functions. So now finally I can say that C++ allows two things to happen. Don't make virtual, that function will be called. Make it virtual, this function will be called. So everything is in the hands of programmer now. Whether he want to make it virtual or not, that is the decision of a programmer. What he want, let him decide and do it. Right? So C++ allows both. Non-virtual, that will be called virtual, this will be called when base class pointer, derived class object in that situation and calling this function. So that's it. This is the concept behind the virtual function and the mechanism of virtual function. So in the next video, I'll show you more about virtual function.